All right, let's get right into it. We're going to tackle one of the most famous but also one of the most misunderstood ideas in all of physics, and we're going to use it to solve a really cool puzzle about light. You know this one, E equals mc². You've seen it on t-shirts and movies. It's basically the global symbol for genius. Everybody recognizes it. But what's it actually saying? I mean, really? Most people connect it to atomic bombs, this idea that you can turn matter into a whole lot of energy. And yeah, that's part of it, but it's just scratching the surface of a much, much deeper story. And that deeper story is exactly what we need to solve a weird little paradox. See, we all know light has energy, right? You can feel the sun's warmth on your skin. Solar panels use it to generate electricity. But physicists tell us that particles of light, photons, have absolutely zero mass. So how does that work? How can something have energy but no stuff to it? Well, believe it or not, E equals mc² gives us the answer. Let's dig in. So, to get to the bottom of this, we first have to do a little unlearning. We need to tear down the common sense idea of what mass even is, because it's probably not what you think. Most of us, we grow up thinking that mass is just the amount of stuff in an object. A bowling ball has more stuff than a balloon, so it has more mass. Makes sense, right? Well, it turns out that's just wrong. Einstein's big breakthrough was realizing that mass isn't a measure of stuff, it's a measure of energy. And that right there is the big secret of E equals mc². The equation isn't really about a magical conversion of one thing into another. It's about what mass already is deep down. This brings us to a super important idea called rust energy. Just think of it as all the energy that's locked up inside an object, even when that object is sitting perfectly still. All that bundled up, internal, trapped energy, that is what we measure and call mass. So the m in the equation is really just a stand-in for an object's rest energy. So where's all this internal energy coming from? Well, think about it. Inside every single object, you've got atoms that are constantly vibrating. You've got these incredibly powerful nuclear forces that are squeezing protons and neutrons together. All of these little energetic dances and interactions are happening all the time. You add up all of that energy, bundle it together, and what do you get? Mass. Here's a simple way to picture it. Imagine an object's mass, its rest energy, is like the books inside a backpack. That's its internal weight. Now, if you start running with that backpack on, you have more total energy, right? You've got the energy of motion. But running doesn't magically create more books in the bag. The energy from your movement is totally separate from the energy that's just sitting there inside the backpack. Okay, you with me? So, if we accept this new rule that mass is just a nickname for rest energy, we can finally go back and crack the puzzle about light. And the logic here is actually super clean and simple. Let's walk through it. Step 1. Mass is a measure of an object's rest energy. We got that. Step 2, to have rest energy, an object has to be able to, be at rest. It has to be able to sit still. And here's the kicker. Step 3. Photons, the particles of light, never stop. Ever. They are always moving at the speed of light. They physically cannot be at rest. So, if a photon can never be at rest, it can't have any rest energy. And if it has no rest energy, it has no mass. Boom. Puzzle solved. Now, just a quick side note here. You might have heard about an old, kind of confusing idea called relativistic mass, where an object gets more massive the faster it goes. Physicists have pretty much thrown that idea out because it just complicates things. The clean, modern way to think about it is what we just covered. Mass is rest energy, period. It doesn't change when you move. And this isn't just some weird fact about light. This whole rethinking of what mass is has a pretty wild implication for you. So get this. If you were to take your body and add up the individual masses of every single fundamental particle inside you, all the quarks, all the electrons, all the stuff, you'd only get a tiny, tiny fraction of your total body weight. About 95%. That's right, 95% of what you call your mass doesn't come from your particles at all. It comes from the colossal amount of energy that's binding all those particles together. So in a very real, literal sense, you are mostly just a beautifully organized structure of trapped energy. So if you take one thing away from all this, let it be this. Mass is not stuff. Mass is stored energy. Light has tons of energy, sure, but none of it is stored. It's all energy of motion. And that's why it's massless.
Which kind of leaves you with a pretty big question, doesn't it? If the solid ground beneath our feet, and even our own bodies, are fundamentally just condensed, organized energy, what does that say about the nature of our reality? It seems the universe is a lot less like a collection of static things and a lot more like a dynamic ocean of energy. Something to think about. Thanks for watching.